make it. And that's where you've started really controlling the process of writing a heap overflow. And you can't see it very well there, but it will be on the website shortly. So not only do you need to know the structure of the heap, but you need to know the data on the heap. And essentially, the step that heap overflows have moved to, the reason we say they're still alive and will remain alive over the next conceivable future, is that you can take a lot of advantage of the content of the chunks. And now you can do that in a sort of more automated, much easier to use fashion. It's no longer a theoretical, I wish I could do that. It is now my exploit works because I did that. And in order to do that, we have to look at heap data and then be able to tell you what type that is. So in the heap, you do a heuristic and you say, it looks like a linked list, it looks like a string, or it looks like this data or that data. So the most important, in sort of a trivial fashion, is the doubly linked lists that are everywhere on the heap. Because everyone has a double linked list on their heap somewhere. And if you can move a chunk from the doubly linked list into the chunk that you overflow and then have that double linked list free itself or otherwise manipulate itself, you now have another perfectly good write 4. And you can do all that using the data discovery stuff. See the awesome screenshot in light green? Maybe we should have turned off the lights. But essentially, what you're seeing here is it says, here's the chunks in the thing, and here's the data in them and what types they are. And then at the bottom, I think there's a linked list, which is what we ended up overflowing. So, I mean, the fact that you can script this up and then on your fuzzer side sort of fuzz stuff and just see, did any data structures get on the heap after my data that I think are useful? Anything at all? What does it look like? Are there function pointers? Are there, linked list, structures of strings, that sort of thing. So, yeah, a lot of the stuff that we talk about here sounds very easy in theory, and then you end up going to do it, and it takes you 6 months, which may be an investment you can make, and it may not be an investment you can make. And you start seeing a sort of drop off of the people who can invest that kind of time and energy into writing one heap overflow, which is okay with me, but speaks poorly for the future. So we tried to automate some of that, the heap layout creation, the heap filling, the memory leak finding, and we have that, call it fuzzing the heap. So you can ask the questions like, I'm in a chunk, tell me what is in the other chunks near me, and that sort of thing. And maybe try something else and tell me again. And once I get a different answer, that might be worth manual analysis. So, and again, this stuff's all freely available and easy to use, I think. And if you have any questions, we have a forum where people answer you 24 hours a day. And this is sort of what it looks like. You see that he's checking a chunk and tells you what's up. And you will notice that we have nice colors and everything too. So let's say that, for example, you had an overflow in Internet Explorer or LSASS or Exchange or, I don't know, you pick something big. They usually are doing something in the meantime while you're doing it. So you're overflowing that process, but they have timers and thread pools and all sorts of craziness and logging going into the background. Those are all going to be doing allocations, and if you start slowing the process down by hooking using int3s, all the allocations, because you want to watch a stream of allocations, they do something very different from what they would normally do. And this means that you can't use OllyDbg to write heap overflows, essentially. Because OllyDbg uses up all the CPU, and that means that the process does something completely differently under the memory allocations than it would normally do, which means your exploit only works when OllyDbg is attached, which is not what you want. So we have an inject hook, which is just a quick little API you can use. And it maps some memory in the process, adds a little, sort of creates a little function in the process that it will then call into. At any time allocate heap or free heap gets used, and it will log that data in the map memory space, at which point you can retrieve it later. So the idea is you hook the things, you run your little fuzzer, it fills up some memory, and you pull the data back and you see what happened, which is just as fast as running the program normally and allows you to do some of the more complex heap overflows. But I will warn you, if you do about 1,000 or so inject hooks, you'll notice that the process stops working the way you were hoping. And it's quite simple to use in Python, of course. And so you hook it up, you give it a tag, and then you can pull the data out of that tag. So this is, the future. We're working on heap simulators. We're working on the heap fuzzers. We're working on integrating it with automatic sort of exploit writing toolkits. And being able to find out exactly when heap overflows happened is sort of the beginning of what we're doing in the future. And we can automate a lot of things that we do now, doing protocol analysis and all that good stuff. So here's where we are, and where we are today hopefully is not where we're going to be tomorrow. It's become extremely costly to write heap overflows, but using the right tools, this does defeat XP Service Pack 2, and it does it in a way that they're not going to fix. And it will defeat Vista probably next month. And it'll take on 2003 SP2 as well. So these techniques work, and you can download the debugger for free, and then you can learn how to write overflows, which is fun. And of course, on older Windows platforms, it will generate a reliable heap overflow much, much faster. So if you're looking at Windows 2000 or, for whatever reason, NT4 or a custom allocator that doesn't have protections, this is going to help you 100 times more than what you're doing before. And of course, we have a forum that you can log on to at forum.immunityinc.com, and you can feel free to email me. And that is the talk. And we have, I don't have a demo, but I do have a copy of it running in the background. So if anyone needs a particular question, maybe I can answer it in an actual debugger. Does anyone have any questions? Rich, how you doing? Yeah.
You clearly made a decision to stay focusing on the endpoints and focusing on PC type systems with a commercial operating system.
Yeah, we can only bite off so much.
Yeah, I was just going to say, what was your thinking behind that? Why did you choose to stick to looking at operating systems like books rather than move outside the operating system and start looking at other devices on the network or other devices entirely?
Yeah, I mean, that's a good question. I think there's probably a lot of interesting research to be done on embedded devices. They require a different level of investment. This is something that a team of 13, 14 people can do well, we thought, as opposed to something that would require sort of a much more massive upfront investment before you started seeing. And of course, the market for us is still bread and butter is Win32 overflows. And that's what people run. And probably there's another good market out there that maybe someday we'll approach. What are you up to? Oh, yeah, sorry. I didn't repeat the question.
I was wondering, how long do you think it will take before actually exploiting the low-level vulnerabilities like overriding function pointers become so hard that instead of that, I think you mentioned overriding a structure that contains some security token?
Yeah, I mean, it's not hard yet, so...
Yeah. How long do you think it will take before that gets to the point where instead of actually attacking that kind of low-level functions of more like the operating system even, or the heap, when it comes to the point where instead of that you're attacking the actual data that the process uses instead of the structures that store the data?
And that's what this is. We don't attack the metadata anymore. We only attack the data in the heap.
But you still, as you said, you were attacking you were looking for a linked list. Sorry, you were looking for for instance, a linked list inside the heap data, not like.
Right.
So you're still attacking a low level.
Yeah, and it is a sort of programmatic And we have had moderate success attacking sort of cryptographic tokens as well, but I like having shellcode run, so by default I'll go for that first. But yeah, I mean, you're starting to see a lot of, there's a lot of research going on in finding out, and I don't know where that slide has run off to. Here, you find a lot of stuff looking at like cracking an SBox into, or the problem then is you have to restore it at some point because otherwise people can't log in except for you, and that makes them worried. But maybe that's not a problem. Cool. Well, thank you for talking. Hopefully you'll download the debugger and chat with us online about it.